the wrong answer key. Why do I own that one? This should be on January 2015. Ah, there we go. I was all excited because this is the last one. It's not the last video I have to do, but it is the last exam. I feel like it's the last video, but it's not. This is going to be Mr. Key for January 2015. I hope that's what you're here for. This is just my little disclaimer. If you're here to copy my answers, you're in the wrong place. If you're here for comedy hour, you're definitely in the wrong place. Just ask any one of my students. They'll tell you my comedy's terrible. If you're here for coffee commercials, a little bit of Brugger's, you're in the right place. Free commercials for Brugger's. Come on, Brugger's. Cut me some slack, man. I've been giving you free advertisement forever. But if you're here to learn, if you're here to check your answers, or if you're here to just get some information on how to do some of the problems that you didn't know how to do, yeah, I could talk really fast, then you're in the right place. If you like what you see, not the face, nobody likes the face, but if you like the work product that I'm providing to you, please do me a favor. Subscribe to my channel. The more subscribers I get, the more money I get. No, I don't. I'm just kidding about that. But I do feel better, and I could do maybe some more things if I had some more subscribers. So if you like it, subscribe. If you get 100 on your test and use my videos, please email me, Ken Krause, Krause, it's on the shirt, at gmail.com. All right, let's get going. We've got a triangle. Perhaps it might be in our best interest to actually draw a triangle. We might want to label it F, G, H. And then we might want to say, hey, not like that. Hey, F, which is opposite F, is 6. And G, which is opposite G, is 9. G, that's easy. And angle H is, oh, look at that, right there, 57 degrees. Now, what I'm thinking is, before I even look over these answers, because I haven't looked at them yet, I'm just kidding, I really have. Yes, it's coffee. Stop asking. I'm thinking law of sines. Excuse me, law of cosines. Oh, look, law of cosines. Crazy. I want to find H. Well, H is right here. So if you remember correctly, if you have your formula sheet out, which I have somehow miraculously, wait, I think I have it. No, that's not it. It's not even close to being around. I had a place where I can mess with it. Let's see. Oh, I know where it is. I put it in unit 11 down here on my formula sheet because I was messing with it. Let me delete this stuff. But if you look at your formula sheet and you look at the law of cosines, it always gives it to you with A's and B's and C's and all that stuff. But what I really want you to remember is it starts with a letter and ends with a letter. So those letters have to match. So when I'm looking at this, I'm thinking, wow, okay, I know I've just put about 6 things on the screen. So pause it and rewind it if you need to. But look, I've got, what I have here is H and H. So those should be opposite of each other. So what I'm looking for is H and H opposite each other. Well, H is 57. So I'm looking for H and cosine of 57. So it's one of these two that I'm looking for so that they're opposite of each other. Get off my screen, you dumb son of... All right. So then if I go back to my formula sheet, it says it's B squared plus C squared, or basically just the other two sides squared, minus 2BC. So let's go back, see what we got. Why does it keep doing that? I'm not feeling the love here. So I need a 6 and I need a 9. 6 squared, 9 squared. Well, those are 6 squared and 9 squared. But here's where the mistake is. 2H and 2, 6, 9. And I don't want H's in 2 different places. So clearly the answer here was... number 2. Yay, I got it right. I'm 1 for 1. Oh, crap. All right. So which of the following can be modeled by this equation? Blah, 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 blah. Ooh, this looks so complicated. Well, first of all, I'm pretty sure it's not going to be, well, I guess it could be one of these two. It'd be kind of stupid, though. But let's see what we got here. Boy, if they gave you 3 or 4 with the answers, I'd be really shocked because 3 and 4 are kind of obnoxious. I'm going to look over. I don't think it's 3 or 4. I cheated. So negative 2, 5. Negative 2. I'm just going to go a quick sketch on what's going on here. 2, 3, 4, 5. Bam, right there. And then negative 1, 4. That's right there. And then 0, 3. That's right there. And then 1, 4. That's right there. And then 2, 5. Wait a second. If I draw that, isn't that an absolute value? It sure is. Normally, I would see my absolute value centered here at the origin going ka-chang this way and going ka-chang this way. So, what happened? Well, we had a vertical transformation up 3. Now, just as a little reminder, if you have a function f of x and you're just given the absolute value of x, that's this one in blue. If, though, let's go green. If, though, I move, let's say, the vertex over here 1, 2, 3 spots, and I move it up, that would be f of x, and that would be the absolute value of x, but we'd be moving it to the right 3. And remember, if you're moving right and left, it's actually backwards, so minus 3. But that's not what we did. If I moved it this way, on this one, this would be f of x equals absolute value of x plus 3. But I didn't move it left or right. I moved it up. And if you move it up, that is simply just adding on to the end. And there's your answer. I got to write. Whoa. I get scared when I see logs. Logs scare me. Got to drink some coffee before I handle the log question. Sorry, I'm feeling a little under the weather. Coffee's going to help. Might be drinking a lot of it. You'll get used to it. So, here, kids, is your arch nemesis. Now, if you hated logs, you got to stop. They're nice and fun. So, in order to solve a log question, we're going to turn this into an exponential question with no more logs. Yay, no more logs. So, what it is it's all about that base, all about that base. Okay, I'm a little weird. You'll get used to it. So, here's the base, A. It's all about the base, A. And then what we're going to do is we're going to switch these two. Okay? I'm not going through the whole lesson on how this is done. That would be boring. I want you to remember, oh yeah, you write the base and you switch the other two. A to the y is equal to x. If you do that, I'm going to guess the problem's pretty easy. Where in the world's the answer? There it is, choice 3. A to the y equals x. Woo! 3 for 3, 3 for 3. Page width. Ooh, what's going on here? Which expression is equivalent to the sum of the sequence? Oh my goodness. This looks kind of tricky. Gotta drink some. So they're going to kind of trick you. All right, so we got to get a 6 to start with. So let's see if we can get a 6 to start. So remember, these are the starting values. And these are the ending values. So what you want to test is the beginning and then the end. And you want to check to see what is the beginning number and how can I generate it and what if it the end. The in-between probably work themselves out. You can check those as well. So let's check. 4, I'm going to check the beginning. So on this one right here, it's going to be 4 squared minus 10. That would be 6. Ooh, that works. So I should check the end. The end is 7. 7 squared minus 10. That will be 49 minus 10, which would be 39. Oh, wait a second. 2, 3, 4. I got to figure out what the 7th term is. Oh, wait, no, wait. This is the first term, second term. So this is the 4th, 5th, 6th, 7th. No, it doesn't work. Gone. We're going to start with 3. Oh, you son of a... Fractions. I hate fractions. We can do it. So 2 times 3 squared over 3. We're checking the beginning. So this is 2 times 9, which is 18 over 3. That's 6. Ooh, that looks good. And then we're going to try the last one, which is 6. So 2 times 6 squared divided by 3. Well, this would be equal to, let's see, that's 36 times 2, which is 72, divided by 3, which is 24. Shoot! Such hang gone. Let's try this one. We're going to plug in a 2 to start. So 5 times 2 minus 4. That's 6. 5 times 5 minus 4. That's 21. Now, don't just assume that the last one's the answer. That would be estupido. Nicht so intelligent. Abisle dum. Kind of stupid. Don't do it. Check. Maybe you made a mistake earlier. Let's check. 2 squared plus 2. That's 4 plus 2. That's 6. Yay! 5 squared plus 5. Remember, n squared plus n. 5 squared plus 5. That's 30. There's our answer. Yay! Four. Oh, whoa, what's going on? Hey, y'all. Into his house. So we're going to compound our interest quarterly. Well, we're going to start. This looks kind of difficult, huh? Well, clearly this is not a straight line, so clearly it's not this. And I hope that you clearly understand it's not that one as well, because it ain't doing no wiggly diggly thing there. I hope that you recognize this as being an exponential function. It's got an exponent as a variable. It's an exponential function. And therefore, it must be choice 1. What I want to see is if I can get this to look like in a graph. Well, I'm going to have to make up a p-value. So I'll maybe make a p-value up, let's say 10. I don't know what that is. I'm going to say it's 10. And then 1 plus r is 0.05 over compounded quarterly means we're going to divide by 4. So 4 to the 4t. Now, I know it said 50 years, but I don't really care about the 50 years. The t is actually the variable. This is t going this way. So let's see if I can get a quick little sketch of what this thing looks like. Hopefully I don't have any more graphs in there. Good. So I said I was going to start at 1, parentheses, start at 10. 1 plus control division. That was 0.05. It was 5% over 4 compounded quarterly. To the 4t, raised to the 4 times, in this case I'll have to use x because x is my variable. And when I press enter, you're not going to see a whole lot. So what's that thing? I don't get that thing. So maybe what I can do is just grab this thing and move it down. And maybe that's not even good. Let's go change the window. Window and zoom. And then we'll go into zoom settings. And really all I want to see is an x-min of maybe 0 and a x-max of maybe 20 will be fine. But this is the key one. The minimum of y, I don't want to see less than 0 for y. And doesn't look like 20 is going to be good enough. Let's try to go to 200 and see what's going on here. That's kind of uneventful. How about we go menu, zoom, and we go zoom fit. Maybe that'll, oh, there we go. That looks nice. And that kind of looks like choice 1. Zoom fit kind of helped out there a little bit. But I hope what you mostly recognize was it was an exponential function, and this is clearly the exponential function. All right, moving on. Almost done. Which equation has real and unequal roots? Oh my goodness. I'm going to show you guys a couple of cool things about this. So real, rational, and unequal roots. So I'm going to show you the hard way, and then I'm going to show you the other way. The hard way is to look at the discriminant, b squared minus 4ac. I'm actually going to show you 3 different ways to do this problem. So I want to look at each one. So if I take this first one, b squared is 100 minus 4 times 1 times 25. That's 0. That's real, rational, and equal roots. Anytime it is equal to 0, it's real, rational, and this is the key, equal. I don't have equal, I have unequal. So that's not the answer. I'll do this one. 25 minus 4 times 1 times 4. Well, that's 25 minus 16, which is 9. That's real, rational, and unequal. Now, the reason it's rational is because I can take the square root of 9. So there's your answer. I'm done. It's choice 2. But let me just go through and show you the other two. 3. 9's minus 4. 9 is 3 squared minus 4 times 1 times 1. I get 5. This is real, rational, irrational. That's the key. Irrational and unequal. And the reason it's irrational is because, I mean, although I can take the square root of 5, it's not a nice number. 9, the square root of 9 is 3. That's easy. Square root of 5 is 2.7 something, or I don't know what it is, something like that. So let's do this last one. This one's going to be the most interesting. It's 2 squared, which is 4, minus 4 times 1 times 5. Well, if you're not careful, you're going to get the wrong answer. This is actually equal to negative 16. And if I took the square root of negative 16, wouldn't I end up with 4i imaginary? So if the answer was about imaginaries, that would be the answer. Okay, now having gone through all that, that's one way to do that problem. The other way to do that problem is to use our calculator. And let me show you what the different ones look like. So I'll just hit, and then we'll go back in. And so the first one was, I'm going to do it like this so that we can do this as quickly as possible. The first one is, holy mackerel, maybe I can't do that too small. That'll be better. Okay, so, and hopefully my big head's not in the way. We're going to do x squared plus 10x plus 25. And if you do that, you'll notice it hits just one time on the graph. Therefore, one double root. The roots are equal. If I choose the next one, and I delete this, and I go x squared minus 5x plus 4, you'll see that it hits, look, it hits at 1 and it hits at 4. 2 very nice roots. So that's the answer. And when you see it hit nice roots, that's when you know you're at the answer. Nice answers. I'm going to show you a different way to do it in just a second. So minus 3x plus 1. Look, it's hitting, but they're not nice numbers, right in the middle there. Sometimes there are, though, because they give you like a half or something like that. So you got to be careful with that. But notice that where it's hitting right here and right over here are not very nice numbers. And then let me show you what the last one looks like, just as a kind of a, you should have a clear indication. And hopefully you already know what this one should look like. But we'll do minus 2x and then plus 1. And you should see, oops, plus 5. I thought that wasn't going to work. Plus 5. You'll notice here that it never hits the axis, and that means you have to imagine that it has roots because it has no roots. So that's the second way to do it. And finally, I can use menu 331. So let's go into the calculator and do menu 331. We're going to use our poly tools and solve this thing. So the first one, the roots are, the A is 1, the B is negative 5, and the C is 25. Oops. And the C is 25. And I'll click OK, and it says, is this the root? Is this the polynomial you want to solve? Yes. Oh, look. Oh my gosh. No, it's not. What the heck was I typing in? This should have been a plus 10. So let me delete this. This is how we're going to change them anyway. Plus 10. X. There we go. Negative 5 and negative 5. Roots are equal. 2 roots that are equal. Okay, let's try another one then. Let's try the next one. The next one is minus 5 x. This might give you a problem. Plus 4. Let's see if it gives you a problem. I don't know. 1 and 4. 2 rational unequal roots. All right, let's try another one. Let's see. Let's try this one. Now, you're going to see some crazy stuff happen on that last one. Let's see. This is a 1 and a minus 3. And look. Woo! Crazy answers. Crazy answers are irrational answers. Now, the last one's quite interesting. Let me show you what happened on the last one. Let's see. This is a plus 5. And a minus 2, right? Come on. Minus 2. It's not going to give you anything. It's not going to give you anything. In this case, because the answers turned out to be imaginary, you have to use menu 331. Oops, clears. Menu, 3, 3, and complex roots. Not 3, 3, 1. You have to find complex roots. And therefore, you'd have to actually type that in again. Not going to bother. But, oh wait, I got all kinds of issues on this thing. But anyway, it will find complex roots too. I don't know why it just did that. I thought it worked. Menu, 3, 3, 3. Something's not right. I don't know. Anyway, there is a way to do it. Oh, I know. Menu, 3, 3. Oh, you just change this to complex. That's it. You just change that to complex. You hit OK. Sorry, I forgot about that. Then it's 1, -2, and 5. You hit OK. You hit Enter. And look at that. It gives you imaginary roots. And it tells you what those imaginary roots are. Isn't that cool? Wow, 3 different ways to do a simple problem like that. Let's get moving. Come on, let me move down. Oh, here we go again. Come on, catch up. All right, so what's this question asking? I'm going to read it over here. It says, which statement is true about the graphs of f and g? Let's see. F is this function with these curves on it. And if I look at f, f is a function. It is a function because it passes the vertical line test. Even here, because these are asymptotes. So f is a function. So f is a function. Both f and g are functions. Neither f nor g is a function. So I can get rid of that. Now, the reason g is not a function is because it fails the vertical line test right here. It's got repeating x values. So g is not a function, so therefore there's your answer. That's a lot of work for just that simple answer. All right, what is the common ratio? Ratio. Ooh, ratio. I'm going to guess then we're looking for a geometric sequence. We're not looking for the common difference, we're looking for the common ratio. So what do I have to do is I have to take this one, 3/4, and divide it by -1/2. Remember, what we're looking for is what we have to multiply 1/2 by, or -1/2 by, to get positive 3/4. Well, clearly that answer is negative. Oh, they're all negative. That didn't help out. All right, so what you do is you just take the second one and divide by the first one. Well, when I divide by a fraction, what I really want to do is flip and multiply by the reciprocal. And this would be -6/4, which is -3/2. But don't rest on that. I mean, I'm guessing that's probably our answer, but don't rest on that. Let's check the next one. -9/8 divided by 3/4. Again, we're going to do the same thing. We're going to flip and multiply. So I get -36 over +24. And 12 goes into both. 12 goes in here -12 times, and 12 goes in here -3 times, and it goes into 12 goes into 24 twice. So there it is. There's our common ratio. Yay! We're getting close, kids. Woo! Remember, if you get 100, please email me. Let me know what school district you're from, what your name is. I'll put your name up in lights on my website, tell you that you got 100. And although I wasn't your teacher, maybe I had a small part in you getting a good grade on your test. How many different ways of teams, keywords, of 4 members can be created from a class of 20 students? So I have 20 students and I want to make teams of 4. So your choices are very simply, do I pick P or do I pick C? Do I want 20 P4 or do I want 20 C4? And guess what? Both answers, I am certain, are there. Let's try this. Let's get out of all this garbage. Let's clear this up. Menu 5, 3 is combination, so we'll do 20, 4, 48, 45. There it is. And then when we do P, menu 5, 2, 20, 4, guess what it's going to be? 116,280. So, although both answers are there, first of all, we're down to a 50-50 guess. Not the right answers over there. But why is the answer 3? The answer is 3 combinations because it said teams. If you put a group of 4 people out there as a team, is there anything distinguishing how they were selected? Is there anything special about the fact that you picked one first or the second one third? There was no difference in order. You just got 4 people out on the court, out on a team, doing something. They're on a team, and it makes no difference how they were selected. And if it makes no difference how they're selected, you choose combinations. Love you guys. Nice job. Alert, 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 alert. Reference sheet, kids. Reference sheet. Double angle. See it right there. Bam, bam, bam. You know what that says? It doesn't say 2A. It says, look at your reference sheet, dummy. And if you knew that, take off the dummy and just say, I know. Copy. So we go to our reference sheet. First of all, let's think about this. We have only sign here to pick from. So I'm going to my reference sheet. I have 3 to pick from. Which one is the only one that has sign? Oh, look, there it is. The other one has cosine. That one has cosine and sine. That's too much work. I don't want that one. So I'll come back over here. I know what I got to do now. I got to make this thing bigger because it's too stupid to realize. I want it to stay big. So I want to use the formula cosine 2a off of my reference sheet is equal to 1 minus 2 squared. Now, I'm going to type in 1 minus 2. They told me it's 3/8 squared. Now, watch what happens on the Regents exam. Let me show you what I love to see on the Regents exam. I don't really love to see this on the exam. I'm going to put that over there so you can see it. I get 1 minus parenthesis, control division, being really careful to get all this in there correctly. And I put a squared on there, and I get 55 over 64. Oh, yay! I got the right answer! No, you didn't. They suckered you. Don't fall for it. They're always going to have the wrong answers. We know what kids make. We know the mistakes you make. Take a look at this thing. Maybe you saw it when I was typing it in. Did you see the mistake I made? Can you find the mistake I made? Oh, yeah, I make mistakes all the time. I forgot the 2. I forgot the 2. See the 2 right here in the equation? You got to put that in. Enter. Oh, 23 over 32. Let me erase so that you guys don't fall for it. 23 over 32. This is the correct answer. But if you forget this 2, which is very common, that answer will be there too. Triple, quadruple. Stay for 3 hours. Work your butt off. You deserve it. School's almost over. Summer's not coming any sooner if you walk out at 2 hours or 3 hours. But you're going to be a lot happier if you stayed the whole time and look this thing over so you don't make mistakes. God, I hope I get to get 100. I can't even speak English. I want a kid to get 100 so badly. Let's move. When factored completely, first of all, you generally want to look for the most factored ones. So I'm going to guess it's probably this one or this one because they're the most factored. As a matter of fact, you see this right here? X squared minus 9. Not going to be the answer because that's not fully factored. These, number 4 could be the answer. I don't know. So what we do is you take a look at the first 2. Boom, boom. Take a look at these 2. I'm going to show you 2 ways of different to do this problem. Back up. I'm going to show you 2 different ways to do this problem. Do you like my reverse? I just reversed that. I'm like freaking comedian or something. Out of these first 2, I can take out an x squared, and I'm left with x minus 2. Out of these 2, careful, I'm taking out a negative 9. I am left with x minus 2. So what I have left is, notice that these 2 have this in common. So that goes to my first set of parentheses. My first set of parentheses is x minus 2. And whatever remains is my other set of parentheses, x squared minus 9. And that's why that was choice 1 as my answer. But it can't be right because it's not finished factoring. And this factors to x plus 3, x minus 3. And then those are my 3 parentheses. And that's why it's choice 2. But I could have used my poly tools. Menu 3, 3, 1. It's a real equation, so we'll click yes. And, oh, wait a second. Let's back up the crazy train. Let's cancel. We have 3rd degree polynomial. not second, it's a third degree polynomial. So I need to type in, okay, now I'm going to have 4 boxes to fill. 1, -2, -9, and 18, and hit enter. And yeah, that's my polynomial. Hit enter. Oh, look, my answers are -3, +2, +3. So I look over here. Oh, yeah, this would give me +2. This would give me +3, and this would give me -3. Those are my 3 answers. Okay. All right, conjugate, conjugate. There it is, the most word. Woo, conjugate, conjugate, conjugate. Woo, woo, conjugate. Oh, man, that's annoying, man. All that means is you take the original, which is -3 minus 2i, and you copy it over. -3 minus 2i. But you make one change. This sign becomes the opposite. It is the same thing, but with an opposite sign. Now, if I have to multiply these, that's pretty easy. I'm going to multiply these two together and get +9. And I'm going to multiply these two together and get -4i squared. Now, the reason I did not do the middles is because they're going to fall out. If I do -3 times +2i, that's -6i. And if I do -2i times -3, that's +6i. That's why we do conjugates, so they cancel. Wait a second, that's not one of my answers. Well, you're right. You got to remember what this is. And that's really just, this I squared is really -1. So this becomes -4 times -1, which is +4. So my answer is 13. Gee, Mr. Krause, I wonder if there's a way to do that on the calculator. There is, but you got to remember what conjugate means. Otherwise, you can't do this problem. Let's try it. Parentheses, -3 minus 2. I's down here. I, parenthesis, -3 plus 2. I's over here. And I hit enter. Oh, look at that. 13. Got it. Nailed it. Woo! Two less questions. Two less questions. Why can't you just stay? Someone, if you know how to send it, keep it on pause. Always Zoom with. Send me like a link or something to some instructions on how to do it, or just send me the directions, and I'll be forever in your debt. So, let's talk. First things first. We've got to figure out what the center of the circle is. Right here. It is 1, 2, 3, 4. It's -4 up to +2. That means that in my parentheses, do you remember the formula for the circle? It's radius squared. So it's x, y, and then we put the x part of the center in with an opposite sign, moving it left or right, opposite sign there, and then we're going to put a -2 in there. So which one's got an x +4 -2? Clearly, 2 of these. Now, I got to figure out what in the world is my radius. So, what stupid kids do, I call them stupid because they're just lazy, is they go, oh yeah, it's like 4.5, maybe 5. No, you can't do that. You can't use that point on this circle. What you gotta do is find, oh look, they gave us a nice point right here. It goes through the origin. It even says it goes through the origin. So what you really quickly want to do is just do the Pythagorean theorem to find this radius. So we know this is 4, we know this is 2. I'll just do 4 squared plus 2 squared equals radius squared. No problem. Radius squared is equal to 16 plus 4, which is 20. Wait a second, I can stop. Isn't that what goes in the formula? Yes, it is. This is actually the radius. I don't want the radius. I want the radius squared, which is just 20. I think we got one last question to go. Okay, when you have an exponent raised to exponent, you just multiply those exponents. So this is really equal to 5 to the -1 times a to the -3 times b to the +4. but you can't leave negative exponents. So what we want to do is we want to think about this as being a fraction. If you had x to the negative 1, wouldn't that really be 1 over x? Or another way to think about it, if you had x to the negative 1 all over 1, wouldn't this just come down here and become 1, and there's really a 1 right here? 1 over x. So that's what we're going to do with these. This is coming down, and this is coming down. So what's left on the top is my b to the 4th. What goes on the bottom would be my 5a cubed. Holy mackerel. We're done. Whoa, whoa. What the? Oh, my gosh. This is why we do it. Mr. Krause would never get 100 on his stupid Regents exam. Let's try this again, kids. Back up. Ooh. I should have done that while I was erasing. Let's try this again. When you have an exponent raised to an exponent, you multiply those exponents. So this would become 5 to the positive 2, a to the negative 3, b to the positive 4. And again, because I didn't really erase that, this would slip down to the bottom because it's a to the negative 3 is really equal to 1 over a cubed. So that goes to the bottom. So on the top I have 25b to the 4th all over a to the positive 3. Please be an answer. Oh, goodness gracious me. Kids, that was a lot of fun spending this time with you. Ow, I feel so blessed. If this helped, please send me an email. Let me know. If you get 100 on a test, I really want to know about it. Don't cheat. Work hard. Summer's right around the corner. Yeah. Bye, kids.